I don't know if anybody can lend her a charger or not. But Samantha, I'm pretty sure you've been through this before. You might have a little bit of a different wording from your previous school. I think you said it was Weatherford. But we are skipping ions right now. We are going to come back to them, and we are going to be doing electron configuration, or like what they like to call it here, orbital notation. In fact, I'm going to stop presenting, and I'm going to switch it to my screen. Okay. All right. Let's see. We need to record. Oh, it is recording. I managed to hit that button. All right. So, yes, I know a lot of you did not realize. I mean, it was last second to me at 6 o'clock 2 nights ago that I was going to have to be remote. I'm not sick. My kid's not sick. She was possibly exposed. You know how that drill goes. But before I get into the notes, this was one of the last things that we left off with yesterday. Make sure I'm not muted. No, I'm not muted. Okay. So this was one of the last things that we left off on yesterday. And if you sort of shove helium over here into this missing block, this is your S block. S blocks are only 2 elements wide, and they can only hold 2 electrons total. And when we did our colored periodic table, and I'm not trying to make you flip-flop back and forth, but like my screen, like my face, not my presented screen, this thing that we did, we're going to be blocking off our clouds, and we're going to be putting this little doohickey up somewhere on the side. So your S cloud only holds 2 electrons. They are literally 2 elements wide, 1 through 7. Your P block is this green one over here, and it's 6 elements wide, literally 1, 2, 3, 4, 5, 6. Your D block is your transition metals, and they are 10 elements wide, literally 10 elements if you count them. And then your inner transition metals, the lanthanoids and the actinoids, which really belong right here in between these, your inner transition metals are your F block, and they're 14 wide. Now, on my colored periodic table, if you want to get markers, and like I said, I'm not trying to give you guys whiplash, but I blocked out my S block in red in marker, not colored pencil, my P block in purple, my D block in blue, and my F block in green. And I went ahead and I put Aufbau's principle, which we've not quite gotten to, up here on the side. And if I wasn't stuck at home, we would be doing this in class, but unfortunately I am here at home. So you don't have this on your notes. What I used to call electron configuration, they call orbital notation here. It's just a different phrase for the exact same thing. And this is a tie over from yesterday, especially if you were not on the Google Meet, because we're all sort of learning this all at the same time right now. But there are 4 electron clouds that actually hold electrons. There's the S, holds 2. And like I said, it's literally 2 elements wide, group 1A and 2A. There's electron cloud P, which holds 6 electrons. It is 6 elements wide. It is group 3A through 8A. Now remember, helium really belongs with the S's. It's sort of out of place. These 2 are called representative elements. And now I know you do not have this on your note sheet. It's just more of a recap. Your D block are your transition metals. They hold 10 electrons. They are literally 10 elements wide. And then your F block holds 14 electrons. So on your periodic table, and since I am sharing my screen, if I got to find where I put it, this one. Okay, so if you bring helium over here, here is your S block, literally 1, 2 elements wide. Here is your P block, Yes, I know not all these are filled in. I'm so sorry, but they are 1, 2, 3, 4, 5, 6 elements wide. They can hold 6 electrons. These are your transition metals. They are 10 wide. These are your F block, which are 14 wide. The periodic table actually breaks it up for you. You just haven't done this yet to your actual periodic table. Let me go back to the right slide. Okay, so now getting into what you guys have, and I tried my best to underline what needs to be filled in on your notes. So, like I said, what I called electron configuration, they call orbital notation here. It's the exact same thing. It's a way that we know that electrons are located around their nucleus. Now, Bohr said they were in rings like a planet, but it was Schrodinger that figured it out that really it's like a 3 generic area, and we can't really predict 100% where any electron is specifically because they move so gosh darn fast. So we've got 3 rules. The first rule is called Aufbau, named after the German physicist scientist that figured this out. And he was the one that says that electrons have to go to the lowest orbital first. It's almost like stepping on the first rung of the ladder. You can't go to the second step until you've hit that first step. Well, for us, that is the 1s level. That is that first rung in the ladder. And then once you take your second step, that's the 2s. The third step is the 2p. Now, it would make sense, and you guys have these on your actual notes, that it would just go in order 1, then 2s, then 3s, and 4s, but it doesn't. The Aufbau just says that we fill the lowest energy first. This is why I don't like putting quant before ions. You can only have a maximum of 8 electrons in the outside shell, which means that some of these guys, specifically your D's and your F's, need to be shoved inside a shell so that you don't go beyond 8. So it would make sense that we do 1s first and then 2s and then all the 3s and then all the 4s, but that is not the way that it works with electron configuration. They call it overlapping because you cannot have more than 8 on an outside shell. The atom is actually forced. Oh, do I have a question? Yes, Nathaniel, you have a question?
You're not saying that. Can you not tie your shoes?
Well, I'm going to mute you because you accidentally unmuted yourself. Okay, so if I go back to here, your periodic table, okay, so I lost what I was saying. Okay, so you cannot have more than 8 in an outside shell. So what the atom is forced to do is to pull those extra electrons inside a shell, which is why when we fill this guy out, because this was 1, 2, 3, 4, 5, 6, 7 down the left side, but in the D it was 4 over here, but it was 3 over here. These electrons get pulled inside a shell so that they do not violate what is called the octet rule. But you can literally read your periodic table like a book. And I wish I was there to help you because it's so much easier in person. Move this out of the way. Okay, so you should have had this added to your Canvas page. This is almost like following the yellow brick road, but it's red. It's not yellow. So you have to fill the 1s shell first. That's that very first ring on the ladder. Then after that, you have to fill the 2s, then the 2p, then the 3s, then the 3p. But if you notice, you don't go to 3d. You have to do 4s before you do 3d. So that previous order that we did, this is not right because of what we call overlapping. To the right slide. This is the order that you're going to fill it out, and I put it on your canvas and in on your page, and I don't know how well you can see my screen, and I'm going to post this onto my YouTube through Canvas. I put map of Aufbau's principle on my periodic table, so you do not need to memorize the order that these shells are filled, but you have to fill the lowest energy first, and they literally work diagonally, just like this. Okay, the next rule, Pauli exclusion principle. You can't have more than 2 electrons in the same orbit. They have to be moving opposite of each other. Now, it's supposed to be clockwise and counterclockwise, but I just use up and down. And in the assignment, the drag and drop that goes along with this, we do use up and down, which is clockwise and counterclockwise. But so Aufbau says 1s before 2s. So the order. Pauli says that you can't have more than 2 electrons in a shell in an orbit, and they must be moving opposite directions. Literally, one is moving up and one is moving down. Hund's rule says if you have multiple orbits, like the P, the D, and the F, that each orbit gets 1 before you come back and you double up with the opposite direction. And none of this is making sense until I show you how to do it. So Aufbau, lowest energy first. Pauli, no more than 2 per orbit. They must be opposites. Hund's, each orbit gets 1 before you double back up with the opposite spin. So we're going to take an example of nitrogen, and I'm not trying to give you whiplash, but I do not know what else to do but to go back and forth. So here's nitrogen. Nitrogen is element number 7. So it has 7 electrons. That the atomic number tells you the protons and the electrons of a neutral element. So I can't stop until I hit the magic number 7. Okay, so I know you guys don't have arrows on your document, okay? And you're welcome to go back and take a look at this through Canvas with my YouTube link. But I personally do ups first. And honestly, I do a half arrow, like almost like the number 1 without the bottom. That's the way I was taught how to draw them, but I couldn't make it do that on Google Slide. So my first arrows are always up, and my second arrows when I come back are always down. So I'm literally going to count the 7. 1, 2. The S shell can only hold 2. Once again, if I go back to here, it is 1, 2, because helium belongs over here. So 1, 2. First shell, second electron. Now I'm down in my second shell. Second shell, 2 electrons. I have not gotten to nitrogen yet. This is my magic element that I'm trying to get to. So I've got 1, 2, 3, 4. Remember, I'm trying to get to 7. Now here's where people mess up. Each one gets 1 before you double up. So I've got 1, 2, 3, 4, 5, 6, 7. Now, in your drag and drop, it actually has this inverted so that the 1s is on the bottom, but you're still going to fill the 1s before the 2s, before the 2p, before the 3s. It's still this order. There's so many different ways to teach y'all how to do electron configuration that this staircase method was the way that I was taught. Now, there's another way to write this. If I want to actually write out nitrogen in configuration mode, you're going to do 1s, 2, 2s, 2, 2p, 3. This, which I know my black bar keeps popping up, but down there on the bottom, that is the configuration of nitrogen. And honestly, that's the only thing you have to look at, because if I go back to this, go to the right slide, and I'm going to go back and forth. So nitrogen, you've got 1s2, 2s2, 2p, 1, 2, 3. And if I go back to the first line that we did, nitrogen is the third one. It's this block right here. It's the third one over in the second row in the P block. It's the third element over. That's the only thing that you have to look at. If they give you the entire configuration is what row, keep in mind the D's jump down, the S jump down. What row, what letter, how many far across do you go? And if I go back to this, okay, so literally nitrogen is in the second row down within the P block, and it is the third element over, which is how you actually read electron configuration. Now we're going to do another one, iron. Iron, if I go back, so sorry, I'm having to do it this way, but I don't know how else to do it. Iron is right here. It's element number 26. I can't stop until I've done 26 electrons in this configuration. Don't cheat and look. Okay, so 26, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I got to go to P, 13, 14, 16, 17, 18. After 3P is not 3D, it is 4S, and I just lost my count. 1, 2, 3, 4, 5, 6, 7. Okay, so 19, 20, 21, 22, 23, 24, 25, 26. So after 3P, you don't go to 3D. That is what I see people do wrong. You have to follow this, which is why I tell you with that cheat sheet that I'm letting you guys use all year long to put off vowels on the front of it. Because after 3P is 4S, then you come back and do 3D. So that means that iron's actual configuration name is 1s2, 2s2, 2p6, 3s2, 3p6, got to go down here next, 4s2, and then 3d6, which now my thing is in your way. Let me move it, and then I'll go away in a second. So they mean the same thing. And like your drag and drop, the actual assignment has the 1s on the bottom. It's just inverted it because whoever did the drag and drop that's how they decided to do it. There's many different ways to do configuration correctly, but you still need to follow filling off vowels principle. Now here's the one that I finally, I waited to record this class because I didn't have platinum done. There was too many arrows. It's like 90 something arrows. Now 78. Platinum. Platinum is down here is number 78. Now I already know that my last thing, so it's 1, 2, 3, 4, but D's are 3, 4, 5. So I already know that the last thing is going to be 5D, 1, 2, 3, 4, 5, 6, 7, 8. I already know that that's the last thing that I'm going to see because that's the way that the periodic table orients these things. I'm going to go ahead if I find the right slide. No, don't cheat. Okay. Load. Okay. 78 of them. So 1, 2. Oh, and there's another way to do this. Okay. So the previous slide, 2 slides, I put the 1S and then the 2S, 2P, and then the 3S, 3P, 3D. If we're really nice, we put them in order for you. And all you have to do is fill them in. Literally. From left to right. And you don't even have to know which order they're filled in, because after 3p is 4s, then 3d. So if I'm really nice to you, I will give you this outlay. So once again, we're going to 78. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Ooh, that's all wrong order. 29, 30, oops. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 78, 59, 60, 1, 2, 3, 4, 5, 6, 7, 8, 9, 70. 1, 2, 3, 4, 5, 6, 7, 8. Oh, so and I cannot remember. Did I put it on here? I don't think I did. I didn't. Okay, so it would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, because there's 10 of them, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, and then 5d8. And once again, if I go back to my periodic table, platinum, so 1, 2, 3, 4, 5, 6, but then it goes 3, 4, 5, because the D shells shove the electrons inside one. We've got 1, 2, 3, 4, 5, 6, 7, 8. It's the 8th one in the 5th D shell is how that is read. Now, if I go back to this, which is your actual assignment, you notice they flip-flop. So instead of the 1s on the top, it's on the bottom, but you still do 1s, 2s, 2p, 3s, 3p, 4s. This is where it gets tricky. 3d, 4p. But on the periodic table, 1s, 2s, 2p, 3s, 3p, 4s, 3d is next, then 4p, which is why this thing is so important for you guys to build correctly. Back to the right slide. Okay, so this drag and drop, I'm getting a lot of people are freaking out because it's towards the end of the 6 weeks and you've not been turning in your stuff. These drag and drops are grades. I'm so sorry. My new student is, I'm going to say it's Austin. I don't know what I just did with my book. Austin, I don't think you have a Chromebook yet. It may take a little while to get your transfer grades. We'll see how quickly your previous school gets them. I think you came from Brewer, I think, if I read right. We will figure this out. I will be exempting you from the notebook check. Now, for those of us that have been doing paper notes, which is almost all of us, I can't take a paper book right now. I'm not even supposed to be, well, not that I'm sick, but I'm not supposed to be on campus. So, well, let me finish with this real quick first. This one just wants you to put them in order from lowest to highest. Austin, I'm so sorry if you do not have a Chromebook. I do not have a paper version. I am so sorry. I'm working from home. With these, y'all, that's your key. 5th row down, S shell, first element across. 2nd row down, P shell, 4th element across. Go into the 4th F shell. If you numbered them right on your colored periodic table, you've already gotten it. It's the 4th one over in that F shell. These guys, what's wrong? What's broken? It's either off bow it doesn't fill it at energy level. Huns says that it's not 1 all the way across before it doubles up. And Polly says that there's more than 2 in a shell and they're not opposite spins. So that should be fairly easy for y'all to get back to me. Oh, I see something in the chat. Are these the notes from yesterday? No, These are not the notes from yesterday. Okay, so from yesterday, because I had so many of you that didn't join in, which is understandable. Things are a little chaotic right now. It's right there. Yesterday was the YouTube link. I will upload today's from you guys because I wasn't ready to do it in fourth period. I didn't have all my arrows animated. Fact. Let me stop recording. Go away. Let me stop the recording.